Okay, so please welcome Denisa Corut from AWS, alebo AWS. Ešte takto switchneme. And this is your time.
Thank you. Hello, everyone. My name is Denisa Corut. I'm Solutions Architect at AWS Services. I'm dedicated for public sector and based in Bucharest, so I don't speak Slovak. And for today, I want to present to you some solutions at the edge, some technologies that you can use for a specific situation into the defense sector, like machine learning, IoT, and my presentation will focus on a use case, on a project that our engineering team, our Envision engineering team delivered for one of our customers in defense sector. And let's start with the business challenge. So, customer came to AWS with the ask to provide a practical example of how they can use our technology at the edge. And more specifically, they were looking to use edge solutions into an operation to respond to disaster response and human relief. So imagine disasters like earthquakes, fire, hurricanes, institutions, organizations need to go in the field, they need to set a mission, they need to locate life, they need to send the right people, the right technology, where the signs of survivors are detected. So basically, this was the ask, this was the use case. What AWS brought to them in a project, a POC that was developed in less than 10 weeks. It is a POC that is focused on sensors network, the positions in the field, into the area of interest, sensors that were able to collect data and report likelihood of survivors in that area without heavy connectivity, because into disaster, there's no infrastructure, there's no internet, there's no communication, so we need to be able to respond as soon as possible without having this into a place or building into a very short time. First thing we need to do is to retrieve data from the sensors and send it back to the edge infrastructure in order to process it. What do we do with the result, with the information after processing, after aggregation? We need to assign a score to identify the probability of having survivors in that specific area. Then we need to notify people in the field. Team, go into that direction and find out what, if there are survivors, what their needs are, medical care, food or shelters. So it requires a way to communicate also to take actions into this kind of operations. And also, they wanted to provide a complete view to the people overseeing the operations, to have a map with all the sensors in the field, to see the scores of human activity, and also to take actions on the fly. So basically, this was the ask, and this was the solution. On a high level, this is how the architecture looks like. I will not get into the details now, but what I want to mention are the three blocks that form this POC. On the left, you see the sensors, which are sketched on the field and that they collect data. The readings are then sent to the Snowball Edge, the pointer, yes, it works. The Snowball Edge device, which is the infrastructure that captures the data and processes it and then aggregates it. Then later on, with this information, we can send the communication to the field operators. And after we have internet connectivity, after we establish or later on, we can replicate this data into the cloud and run further analytics. And let's start with the first block. Here is the sensor device. It's built using a Raspberry Pi board, which has multiple sensors, everything packed into transparent cage, which are dropped into the area of interest by the drones. Raspberry Pi was used and selected because of the large community built around it and because of the opportunity to reuse this solution without many changes. This device is powered by a battery, and it also has a battery controller that offers information about the level of battery and also prevents of discharging in case the sensors are not active. In terms of capabilities, of sensor capabilities, we have here the environmental sensors that measure temperature, humidity, light, pressure, sound, and we consider that this information is important because a change into the environment circumstances can mean that there is some human activity. So, for example, a change in light readings. It can be due to a torch pointed to the sensor, or it can be to a reflection of a human moving, or if there is a change, for example, into the sound, it can be due to a conversation or also to human movement. Other component that you can see here, sorry, I pressed the wrong button. Okay. Another component here, it's a Wi-Fi USB dongle that can identify if there are other Wi-Fi devices in area that are trying to connect to the network using probe frames connectivity. Also, for this specific situation, the team built a network based on 4G, a mobile private network, but it can be also LoRaWAN or radio frequency or whatever connectivity you may want to use. And for the device to be able to connect to this network, it has to have this sensor and also the GPS capability to identify where the device is in the field and to locate their movement, to get their movement data. The box, the sensor device, it also have one for camera, which is capable of capturing still images, but also runs an object inference logic to detect human-like objects. So this is also embedded, as you can see here, into the tiny box. And a very important component here, it's the software-defined radio module that allows us to act like a cell tower in order to identify if there are any GPS devices into the area. So all this can indicate later on, after doing some aggregation and scores, the likelihood of human presence. In order to communicate to the edge infrastructure that we'll see on the next slide, these sensors run AWS IoT Core software development kit in order to publish their readings using MQTT connection. Okay. And here is the second building block. It's the infrastructure deployed at the edge. For this, it was used the Snowball device, which has capabilities of compute storage, and also comes into enclosure that is shock resistant, that makes it very easy to be put on military vehicle to respond to the mission. And here in this picture, you can see the vehicle that the customer provided to AWS just to showcase the operation in action. On this box here, on the Snowball, we have several services, and I will start with the compute, which is represented by EC2, which runs a software called IoT Greengrass, which is a runtime that enables us to build, deploy, and manage the software devices. So basically, this IoT Greengrass subscribes to the MQTT topics that the devices in the field are using to send data. And later on, in order to understand the information, the team builds some custom components. And I will start with the aggregator component, which actually collects data from all the sensors you saw previously, applies some heuristic approach in order to result a score, a calculation that indicates the likelihood of human presence. So how this calculation was made was using some weighted rule-based approach, having some empirical data. But later on, once we collect more and more information, we are able to refine these weights, to recalibrate them using machine learning algorithms. But for this, we need more data, and we need to train them. After we get the information, we understand the likelihood of human presence in some areas, we need to communicate with people in the field. And what you see here, it's an integration with the Tactical Awareness Kit, which is an application for situational awareness used very often into the defense sector. And this was achievable by installing the server on an EC2 compute, and also the people in the field installing the client on their mobile devices, on the iPhone and laptop, and also on the tablet. Now, there is a video here. I hope I can play it. No, sorry. Let's see if it works. If not, I will give up on video. Oh, it works now, yeah, thank you. So what you can see here, it is the position of the devices in the field, and also some raw data coming from their devices. And you can see also the devices movement. So for example, this one was dropped by a drone, and this information is very useful for the military people on the field. But we are not experts in tech, and we wanted to show the possibility of having a web-guided interface for deployment into the rapid manner, for having a more comprehensive overview about what's happening in the field. And this is something that the team built in this time that was allocated for the project. You can see here, for example, the devices also on the map. And here, in a short moment, we will see the live capture of the camera of one of our colleagues who was in the area. What else brings additional to the team, this application? It also provides more details about the readings from the field. So you can get an overview of the scores of human activity around the devices, and you can also get some details about the readings, and to intervene in case there's some troubleshooting needed. And here are the readings. And the last component that we integrated with the Snowball Edge, it's the capability to have an instant messaging with the personnel in the field. And for this, we used an instant messaging solution from one of our partners, because this project was done in collaboration with more than 20 partners and allows to create channels to publish automatically information about survivors or about changes in readings, so they communicate and also get automatic notification. So everything you saw so far, it's without internet connectivity. You don't need to have it in case of, you will not have it in case of the disaster, but you also need to be capable to deploy it in a very short time. And I want to go back a little bit to the custom application, custom web UI that was built for this customer, that shows here the list of devices, and here shows the scores, meaning that 3, which is bigger than 2, based on the calculation I explained earlier, indicates that here it's a higher probability to have human presence. And yeah, it provides details for every device that you select. Once we have internet connectivity, we can go further and make analytics. So we replicate our data into the AWS cloud. We can run analytics, we can run ad hoc queries, and have, let's say, integrated view of business intelligence to see how operation went, to compare it eventually with previous operations, to see what went well, what went wrong, what we can improve. And this can be achieved using the services like Amazon Athena, which is for SQL query, and Amazon QuickSight, which is our BI solution. So this slide, it's an overview, what I presented so far. Everything you saw can be reused. It is a prototype, but it can be replicated. The cost for the sensor units you saw, it's around $500. So there are consumer sensors. The Raspberry Pi, it's widely adopted and can be reused. And also, very important to mention here is that this project was, let's say, a joint effort of multiple solutions, as you could see into the presentation, and it was delivered in less than 10 weeks. So this is the overview of the use case. It can be, let's say, discussed in greater detail and see how it applies to your business case. So this was the presentation. I hope it was interesting.
Definitely it was. So Denisa Corut, AWS Solution Architect. So thank you very much. It was nice when I saw a topic of your presentation. So I said, oh, wow, Internet of Things, that's something which I can understand. But after your presentation, I'm not really sure.
Yeah, so this project was done by a team we have in AWS. It's called Envision Engineering. Mm-hmm. So the team knows what they do. And they work, they know very well also the use cases, the business, and they were capable to deliver this in that short time. And yeah, it was a success, and it can be replicated. That's why I'm here to share with you what it was done at that time. And yeah, maybe...
Okay, you said that can work without internet connection?
Yes.
So how long it can working?
As long as the 4G connectivity that you built for communication between sensors and between the edge infrastructure, it's up and running. And something that I want to mention is that the solution comes with a pre-built stack, with a self-contained stack of networking, so to be rapidly deployed. So the mobile private network that the team built for this prototype, this project, can be deployed quicker now because the stack already exists. It's predefined, of course, can be customized. So as long as the connection it's working, you can collect data from the sensors, send it to the edge infrastructure, processing it, gather data about the survivors, inform the people in the field. And here stops. After you want to run further analytics, create use algorithms to create machine learning models to train them, and to have, let's say, a more comprehensive calculation for future, more comprehensive, I cannot find the word now, inference. This can be done with internet connection, but you can do it later on.
All right, so we have a couple of questions from a slide. So can sensors recognize objects using computer vision?
Yes.
That's a short answer.
What is sensor?
All right, have you delivered any solution to military organizations?
There are solutions, but I don't have knowledge about them. So I'm based in Bucharest, in Romania. In the Central and Eastern Europe, we don't have many customers, but we do have into the US and the other regions. And I can come back with some referenceable customers. This one, I couldn't share the name, but I could share the use case.
Okay, third one. How do you physically deploy sensors to the area? What sensors need to be present in the area before the disaster? Before the disaster.
If it's before the disaster, most likely the sensors are not, let's say, alive anymore. So the sensors were deployed in this scenario after the disaster using drones. But before the disaster, it's a question. I need to take it to the team to protect it somehow. But in case of an earthquake or a fire, you may not benefit of what sensors can collect because they are destroyed. How maybe to put them into a case that can protect from this, but how can you get that the readings, okay, from the camera or from the temperature, the light?
Mm-hmm. All right, that's something which we talk about. How long do the batteries last?
The battery, they use that controller to avoid, let's say, power drowning, and also provide information about the level of charging, so the team can intervene and replace them or recharge them. So I don't know how much it lasts, but this controller that is pre-built into the case offers this kind of information to have control of the batteries and to avoid, let's say, complete discharge.
Right. Look, we have just 3, 2, 1 more second. Thank you very much.
Thanks to you.
Denisa Corut, AWS Solution Architect. Ešte raz teda veľká vďaka.